My name is Steve Coleman. I am a mechanical engineer by education and by temperament. I love engineering. I've been involved with independent business, private business for my whole professional career. I'm now retired. And I was involved with a lot of different things, all often related to energy. And I was also involved with strategic planning and some business development. So I bring that here. It's really not going to be all that relevant to the talk, but at least it's colored who I am. I am a member of St. Denis. Kathy and I, Kathy's in the back, are members of St. Denis. We've moved to Wisconsin about 7 years ago, and we've been members of St. Denis for that whole time. All right, so with that, let's just take a minute and find your prayer sheet, and we'll begin. The prayer has two parts. The first is very short. And what I'm going to ask you to do in this first part is just get comfortable in your seat. Take a nice deep breath. Relax. If you want, close your eyes for just a second. You don't have to. And the prayer's got 4 words. Come, Holy Spirit, come. Come, Holy Spirit, come. And the second part of the prayer has to do with a psalm from the book of Daniel. The bold print is your part, and fine print is mine. Blessed are you, O God, the God of our fathers, praiseworthy and exalted above all forever. Let the earth bless the Lord.
Praise and exalt him above all forever.
Mountains and hills bless the Lord.
Praise and exalt him above all forever.
Everything growing from the earth, bless the Lord.
Praise and exalt him above all forever.
You springs, bless the Lord.
Praise and exalt him above all forever.
Seas and rivers, bless the Lord.
Praise and exalt him above all forever.
You dolphins and water creatures, bless the Lord.
Praise and exalt him above all forever.
All birds of the air, bless the Lord.
Praise and exalt him above all forever.
All beasts, wild and tame, bless the Lord.
Praise and exalt him above all forever.
You sons of men, bless the Lord.
Praise and exalt him above all forever.
Okay. The reason I chose the Come Holy Spirit Come, it's obviously in the season of Pentecost that we rely on the Spirit to fill us and to motivate us and to help us choose difficult paths. Listening to the Lord, having the Lord inspire us. The journey that I'm going to talk about tonight is a difficult path. Putting this presentation together was a difficult path, and that was my prayer often during this, writing for this presentation. We're going to start with, we've got 5 sections to do today. We've already done the first one, the introduction and prayer. The second one is this Catholic social teaching. And I'm drawing on 2 sources here for that. The first is from the U.S. Catholic bishops. This was a 11-page letter teaching that they wrote in 2001. And it's a marvelous paper. It's a marvelous teaching. And I don't know if I wasn't paying attention then, but it kind of went right over the top. I never heard it. I never saw it. I'm obviously going to paraphrase it because it's only going to get a few minutes. The first thing I want to tell you is what the bishops said is they told us what climate change was not. And they said it's not about economic theory or political platforms or partisan advantage or interest group pressures. It's about the future of God's creation and the one human family. That's the Catholic voice. The bishop said, we're not scientists, but we have confidence in the science that's being told us by the International Panel on Climate Change. He says that there's a lot of people working on this problem, and they've come to a consensus, and I'll tell you just a bit more about the IPCC in a minute. And we're going to base our input on their conclusions. And what they are calling for based on that is prudent action. Let me tell you just a little bit about the IPCC, the International Panel on the Intergovernmental Panel on Climate Change. It was formed by the United Nations and the World Meteorological Organization 25 years ago, in 1988. They've been meeting and working together ever since. They review science, technical, and socio-economic information. There are thousands of scientists working on a voluntary basis. There are 195 countries that have joined the IPCC, governments that have joined it. So it represents basically all of the functioning governments in the world. The IPCC provides scientific consensus, and it does not define policy. Policy is left up to the governments. They come together using this information. Now, what the Catholic bishops said is, we're going to trust this information. It's good. And then they gave us a little summary. The summary of that is that the earth is warming. That warming is caused by greenhouse gases, and those greenhouse gases are a result of human activity. So the bottom line here is the earth is warming, and it's a result of our activity. The Catholic bishops then give us two moral questions. How do we fulfill our call as stewards of creation? And secondly, how do we lead the family of nations to the stewardship of common good, especially to the poor and vulnerable? And this is the Catholic voice. And this is our challenge. That paper was 13 years old. Pope Francis, ever since he has become Pope, has been very outspoken about taking care of the environment. You'll hear it mixed in lots of different places where the Pope talks. Just a few weeks ago, May 21st, he gave an audience, and in it, he gave some very quotable stuff. God's creation is good. Creation is not property. We are the custodians of creation. And then he tells us, he gives us our instruction. Safeguard creation. Because if we destroy creation, creation will destroy us. He then continues on for one more quick sentence. Never forget this. This section is quite brief. I wanted to stop here, though, and see if there's any questions. There are hours worth of different Catholic information I could bring to this. They all kind of revolve and reflect around the same thing. But any questions so far?
What is the global warming?
But get right into that, Father. Thank you for the question. That's the next section. What is it? What does it look like? Okay, safe to go on? There you go. Climate change demands action. Who is demanding action? We are, the coming generation. Our world will not be like yours. You have already changed it. We are depending on you. For me, this life hits home. These are my grandchildren. These are my grandchildren who are demanding action. Okay, Father Allen's question. What is global warming? What does it look like? This, to any non-engineer, this is boring. But bear with me for a minute. Let me see if I can bring some life to it. This is 130 years of the average temperature of the world. How do you figure out the average temperature of the world? Well, you take data readings from any meteorological area, and you record them in the day, the hottest point of the day, the coldest point of the day. You average them together, and you get a temperature for the day. You average those together for a week, and you get a temperature for the week. You average those together for a month, and you get a temperature for the month. And you average those months together, and you get a temperature for the year. You do that for 130 years, and you plot out the results. And you can see that some years are hot, and some years are cold, then they bounce along. However, you can see in the last 75 or 100 years, there's been a steady increase in temperature. It's only about 1 degree Celsius, 1.8 degrees Fahrenheit. And you say, how can that make a difference? Look at all the vibration in there. The analogy that I found most helpful to me is that of me having a temperature. Our bodies are 98.6. If our temperature goes up a degree or a degree and a half, we have a fever. And we don't quite feel right. We start to get some symptoms. If our temperature goes up 2 more degrees to 102, we're feeling pretty crummy. We might not go to work today. If it goes up to 104, we're certainly going to go see the doctor. And if it goes up to 106, we may die. So there's small pieces of temperature, but they make a big difference on a complex system. The Earth and its ecosystem is certainly complex. These 1.8 degrees Fahrenheit that we see here are going to make a difference, and we'll talk about some of the things that we see because of it. So this is a thing we can go out and observe. We can take the temperatures, we can do the data. Another thing we can we can observe is for 40 years, just over 40 years, and it comes from tidal gauges. And then the blue squiggle up there is more recent data that comes from satellite observations. This whole area, top to bottom, is only about 10 inches. Okay, we've seen about 10 inches of sea level rise over the last 100 years. And for us who live in the Midwest, is that a big deal? Not so much. Not so much. If you live in Miami, if you live in Chesapeake Bay, if you live on the Jersey Shore and Hurricane Sandy comes along, this makes a big deal. If the sea level is a foot higher and you get a hurricane that comes in, that sea level that comes in is going to be another 3 blocks into your neighborhood. Or if you're real close, it's going to be filling up the first floor and going into the second. The next piece of data that we can observe and view is that of the melting of the sea ice on the North Pole. And this is a 34-year plot of the extent of the summer sea ice. What happens is in the winter, the whole North Pole freezes over, and then in the summer, when the sun's out, it melts back. 35 years ago, there were 8 million square kilometers of ice at the low point. 2 years ago, there was less than 4 million square miles of ice, square kilometers of ice. Do I care? Probably. That polar warming changes our weather. The polar vortex that we all knew and love in January and February, the weathermen tell us that's because the pole was warmer, it was hotter. Whether this is mundane to our lives, let that be. I want you to look at the trend. Okay, we've lost half. That factor has changed by a factor of 2 in the last 35 years. Before I get into the fourth trend that we see of global warming, I need to talk to you a little bit about carbon dioxide. Carbon dioxide is totally what we're made out of. Okay, we eat hydrocarbons, and we take in oxygen. And when we use that food for energy, we exhale carbon dioxide and water. That carbon dioxide goes out to our farmers' fields, and it's combined with sunlight in plants, the process of photosynthesis, to create new hydrocarbons. So there's a cycle. Carbon dioxide is used to grow food, we use the food, and we give off carbon dioxide. It's a very much part of our normal cycle. If you look at the atmospheric carbon dioxide, it will cycle over the period of the year. The reason it goes down from May through September is because the amount of photosynthesis, the amount of growing that happens in the northern hemisphere during that time. Most of the land mass is in the north, therefore the summer of the north is the one that really contributes the most. Carbon dioxide is taken out of the air and put into the plants. Okay, so let's look at a longer period than just 1 year and see what we get. You can see the yearly ripples. Higher at the end of spring, or at the end of winter, and then down to the beginning of fall. But it doesn't go flat. It's going up. And it's going up by a lot. This is a 50-year time frame. We start in 1960. The carbon dioxide in the atmosphere was about 310. This year, it broke 400. Where's that other carbon coming from? How can this happen? Well, in that carbon cycle that I talked about, there is another factor, another actor that gets in. And that is, as humans, we dig into the ground and we dig up fossil fuels. Fossil fuels that have been buried in the ground for millions of years. We bring them up and we burn them, and the carbon dioxide goes into the atmosphere. It was probably 40 or 50 million years ago that was put under the ground. That's a real long cycle. It's not like waiting for the corn to grow. This little chart here shows what happens to the, I got to tell you a little sidetrack. That's this is the engineer in me. And there's a thing called the conservation of mass. Mass is neither created or destroyed. You've got to account for it. So when you get your gas can, you take it down to the gas station and fill it up for the lawnmower. You bring it home, it weighs about 7 pounds. You mow the lawn for about 3 or 4 weeks, gas can's empty. Where did that 7 pounds go? Well, that carbon was made into carbon dioxide, and it went into the atmosphere. There's also some hydrogen in gasoline that went into water, and that's into the ocean. That one takes care of itself. The carbon dioxide doesn't. We, as a society, have burned 9 gigatons of carbon, fossil fuels, last year. Try to come up with an analogy of what is a gigaton. It's a really big number. And I don't have anything for you. I don't have any. I don't have anything for you. It's big. It's a really big number.
How many zeros?
12.
Thank you.
12 zeros in a gigaton. It's 1,000 million tons. There's 9 of those put out every year. 3 of them go back into our green stuff, takes care of them. They go into the land, and they go into growing stuff. And 2 of them go into the ocean. You know, thank you, ocean, for helping take care of some of that. There's a penalty you pay, though. The ocean becomes more acidic. And you'll hear the term ocean acidification. That's because of those 2 gigatons coming from there. All right, I will try to keep going here. These are my four indicators of global warming. These are things we can go out and measure. There's no controversy about them. They've been measured a very long time, and they're happening. Now, 3 of them are just physical observations of nature. The 4th one is a physical observation of the atmosphere. The one up in the upper right-hand corner is being affected by the amount of fossil fuels that we dig up. And so how is it that those fossil fuels, how is it that this increase in carbon dioxide can affect the other? And I'm going to spend a few minutes talking about the basics of that science. So if I get too geeky, fall asleep or something, and I'll move on to something else. I've got to start with what's so special about carbon dioxide. The special thing about carbon dioxide is it's got special chemistry that allows visible light to come through it, but does not allow heat to get back out. And the higher the concentration of carbon dioxide, the more it blocks that heat. So it's a unique gas. Greenhouse gases are unique gas. Carbon dioxide is the major component of that. Our atmosphere is made up mostly of nitrogen and oxygen. Those are ordinary. They let the visible light in and the heat out equally. So that's not a problem. It's the increase of these other things that's the problem. So you start with the sun. The earth is heated by the sun. All of our energy ultimately comes from the sun. Some of it is reflected off of the land, and some of it is reflected off of the clouds. The part that's left over after those 2 reflections heats the earth. The land and the water warm up, and they begin to radiate energy back into space. The trick here is that the energy in has to equal the energy out. An imbalance between those 2 causes an increase in temperature, because the energy's here, and that increase in temperature will then increase the radiation back, but what you're looking for initially is an equilibrium. Energy in is equal to energy out. Now, right here is the atmosphere, the lower atmosphere. And in the next slide, it's going to change color just a little bit. I want you to pay attention to that. There it is. It turned gray a little bit. And that is what the atmosphere happens to the atmosphere as you introduce greenhouse gases. It's like putting a blanket on the earth. It doesn't allow the heat to get back into space as readily. It stays that way until a new equilibrium occurs and the temperature goes up. Put more carbon dioxide in, and the temperature has to go up more to let that energy back out. So this is back to this curve. This is why the concentration of carbon dioxide in our atmosphere is so important. It's the thickness of the blanket that we've got around the earth. I will only spend a second on this one. This is the amount of energy that's being absorbed as it's reaching a new equilibrium. Everything around us gets warmer. The little orange strip on the bottom, that's the energy invested in heating up the air and the surface of the land. Those other two blues, they're the energy that goes into heating up the ocean. That heating of the ocean is what's causing most of the increase in sea level. You heat something up, it gets bigger. That's what we're seeing. Okay, is this something new? This phenomena of carbon dioxide in the atmosphere? This chart is 6,000 years of history. The carbon dioxide is in the blue on the bottom. And this is basically as long as we've had civilization on Earth. 6,000 years captures pretty much all of it. And if you can see, the carbon dioxide level through most all of Earth's history, all of culture's history, has been from 270 to 280 parts per million. Then something happens funny over on the right-hand side. The Industrial Revolution happens. And we start to dig up peat initially. We get into the peat mines. We get coal. Later on, we figure out how to harvest oil and natural gas. So we've gone from 280 parts per million up to 400 parts per million. It's a real ski jump. And similarly, here's the temperatures that correspond to that same time period. If we want to look back even farther, this is 800,000 years of information. And this is gathered from ice samples. And the big blips that you see going back and forth, those are the ice ages. There's 10 ice ages represented on this chart. The reason I show you this chart is because look at where we are right now. We're up at 400 parts per million. There's nothing that we've seen on Earth like this in the last million years. Where does all this carbon come from? This is a map of the world that shows who's contributed to that 400 parts per million. The red, which is the sole possession of the United States, represents 30% of the carbon dioxide that's in the atmosphere today came from us, Americans. Russia and China have contributed less than 8%. India, Australia, Canada are between 1 and 7%. The southern countries have produced like 0.1%. So it's very much the industrialized countries, and it's very much the United States who's put that carbon in the atmosphere. Here's the basics. Mankind has converted long-buried fossil fuels to greenhouse gases at a rate that the Earth has never seen. It's produced them through our power generation, through our transportation, and through our industrialization. I love the lifestyle it's given us. but there's been a cost that we have not been aware of. We're aware of it today. I'm going to switch gears here a little bit, just in my choice of words. The choice of words of whether we're talking about global warming or we're talking about climate change. I've kind of arbitrarily said those four things that you've seen, the things that we can observe, the temperature that our planet has, that's global warming. Climate change is the symptoms that we see from the Earth having a fever. And we're going to get in now to what are some of those symptoms. The first that we hear a lot about is the weather. There's stronger storms. Why? The Earth is warming. As you warm up the air can hold more energy. It has more energy. It's more energetic, and it can hold more water. If you have more energy and you have more water, that's what drives weather. That's the makings of stronger weather. We have more flooding. The rains that we have are often longer and more severe. Let me make sure I get this, I'm fair on this. Climate is not weather. Climate and climate change are things that you look at over 30 years, 50 years, 100 years. A given storm is weather. Okay? And they're not the same. You cannot predict any given storm because of what we see in global warming. However, it changes the probabilities of what goes on. Okay? Storms do become more intense. Now, Hurricane Sandy may or may not have happened without global warming. But Hurricane Sandy, coming an additional 5 blocks inland, that's global warming because the sea level's higher. Droughts. How can we say that both floods and droughts are caused by the same thing? Well, these again are weather patterns. When we're talking about a drought, if you'll allow me to do a mental exercise here, if you're out in the Southwest, very limited rainfall. They have to use all of their rain, all of their moisture very well. If the temperature is hotter, if the temperature is 2 or 3 degrees hotter, when it does rain, that rain is going to evaporate sooner. And it's not going to be as usable. And so again, it's a layer on top of a natural weather condition. Droughts are very important. They're going to be important to us in our breadbasket as to what we get from California, but they're really even more important to those who live in Africa, in southern Africa. Those are very marginalized farming situations, and they are suffering significantly because of it. Forest fires, you hear a lot about forest fires. That temperature rise, the lack of moisture, again, no particular forest fire is going to be said, this is caused by global warming, but the frequency that they happen, that can probably be contributed by it. Even massive snowstorms. Again, does this seem obvious? No. But if you've got a more energetic storm, and you just happen to be in a place that's below 32 degrees, you're going to get more snow. There's more energy in the atmosphere, there's more moisture in the atmosphere, and so that particular storm is going to give you more energy. I need to really keep moving here. I want to talk about ice. The Arctic ice cap is melting. As it melts, it changes the reflectivity of that region. When you've got an ice sheet down, 80% of the energy that shines onto it reflects back into space. If you've got open water, probably 40% goes back into space. There's a lot more energy comes in, stays in. And therefore, that extra energy actually helps melt more ice. So the carbon dioxide gets it started, this ice cycle keeps it going. The jet streams change. Our polar vortex. Pole is warmer. The North Pole is warmer. the differential temperature between the equator and the North Pole is less. That temperature differential is what drives the jet stream. As the jet stream slows down, it gets wiggly. The one that we enjoyed was the polar vortex. Sea level rise, flooding. I talked about a little bit about that, about Hurricane Sandy. Ocean currents. Our weather, the world's weather, is very dependent on ocean currents. As we change the amount of energy that's in the ocean, they're going to change also. The final sequence is on the ecosystem. I'm going to roll right through these. There's extinctions happening. There are a lot of species that cannot handle these changes rapidly enough. They become extinct. Pests and pathogens are changing. We've got the pine bark beetle is hitting our trees up in the Rockies. Agricultural losses, talked about a little bit about that, about the drought situation. Allergies. But the most important is people. People are the most affected by this. And we're affected because we get our sustenance from the climate, from the ecosystem. As we change that, people suffer. Where are the people suffering? The World Health Organization has issued this map. It estimates that 150,000 people die each year because of the effects of climate change. In addition to people who die, there's a lot of people who suffer. This is the big suffering right here. What people are moved out of their homelands because their farms fail. There's floods, they have to move. But let's look at the deaths as an indicator. Where are the deaths occurring? They're occurring in South Africa. They're occurring in the central part of Africa by huge numbers. The next areas are the northern areas, including Argentina, North Africa, the Middle East, and India, the Philippines. And then the gold are people that are able to feel these things but are able to continue to survive. And then look across the north. Very few deaths. Very few effects. Now, if you remember a few slides ago, I showed you another world map. Where's the carbon dioxide coming from? It didn't look like this map. I'll show it to you again in a minute. But where the carbon dioxide comes from and where it affects the world are worlds apart. And this is one of the things the bishops call us to. They're saying we've got to pay attention to this. We are responsible. We have a stake in those people. Here is where the carbon comes from. US, Russia, China. Here's where people are dying. I have two more slides, I think, on the science part, and then we'll move on. I've been talking about history. We've been talking about the last 100 years, 1900 to 2000. If we take the information that we know and we put it into very sophisticated models, what does the next 100 years look like? The black line on the left, that's the temperature rise that we've experienced over the last 100 years. We've got 3 different zones of what it's going to be like in our future. The green zone, it's almost a little yellow, is if we could magically roll the carbon dioxide back in the atmosphere to the level it was in 2000, we will only have another 1.5 degrees temperature rise. We can't do that. We missed that one. But the reason it continues to go up is because the Earth has not reached equilibrium yet. It's going to take another 75 years to get to equilibrium on that old level. The next two, the blue and the orange, these are what happens. These are our choices. These are what do we plan to do today and tomorrow with our fossil fuels. The blue is a very vigorous program that says we're going to reduce a lot of our emissions. And the orange is, the top of the orange is basically business as usual. If we do nothing, we're going to have a very hot, hot world to leave our grandchildren. Similar kind of analysis of what happens as the sea level rise. This is historical. It's about 125 years. Future is 100 years. And you can see the projection going forward. Again, within this band, this is our choices. What are we going to do? How are we going to limit our fossil fuel use? It's someplace between another foot increase and 5 feet of increase. If the sea level goes up 5 feet, New Jersey has a problem. No, maybe you don't have a problem if New Jersey has a problem. Boston has a problem. I have a problem if Boston has a problem. Miami has a big problem. New Orleans has a big problem. Bangladesh has a big problem. A lot of them have a really big problem. The path forward. This is from Dr. James Hansen. He was the leader of Goddard Labs in NASA for 25 years. The blame, if we fail to stand up and demand a change in course, will fall on us, the current generation of adults. Our parents honestly didn't know that their actions could harm the future generations. We, the current generation, can only pretend that we don't know. This is the face of global warming. It's not the polar bear sitting on a floating piece of ice. It's people. I'm going to break here for some more questions. Does anybody have any questions that they'd like to ask? There'll be a third period for asking questions also. Yes?
How much do volcanoes add CO2?
How much do volcanoes add CO2? They do add CO2. They also add particulate matter. The short-term effect of a volcano is usually to cool the earth, because the cloud of dust that they lay in the atmosphere, which lasts for a year or a year and a half, will actually cool the earth during that period. The amount of CO2 that they add is very small compared to our 9 gigatons.
What are the solutions? What are the solutions to avoid the...
Yeah, I've planted you here. I've planted you here. Yes, we'll get right into that. The solutions are not simple. They're not simple at all. Okay, any other questions on the science? How do we respond? The first section is lifestyle changes. We individually, personally, can change our light bulbs. We can insulate our houses better. We can drive less. We can fly less. Bill over here used to put solar collectors on his house. Way to go, Bill. The next time we buy a car, we can think about miles per gallon as perhaps the most important characteristic. Walk, ride your bicycle. So making those lifestyle changes is important. But perhaps more important to that is to adopt a new mindset. We have to change the mindset that we've grown up with. The mindset that we've grown up with is it's fine to dig fossil fuels out of the ground and burn them. We've been doing it. We've been taught to do it. Our society is based on it. The new mindset has got to be, this is my problem to solve. It's not somebody else's, it's ours. And it's particularly ours as Catholics. The Pope and the bishops have told us that. It's our problem to solve. So we've got to put on a new mind. We've got to put on a mind that says, we need to do something differently. We need to adopt some new activities. We need, in this new mindset, to become an advocate for creation. Up to now, we've ignored creation. It's been our waste can. We've just thrown out what we don't want. We need to become a clear voice for change. The Catholic voice. What does that look like? That looks like when you go to the coffee shop and somebody says, global warming, there's nothing to it. What we need is we need something in our pocket at first to say, well, you know, I've been looking at it a little bit. There is something to it. That's tough to do. It might also involve writing a congressman. It might also involve writing a letter to the editor. We need to have a clear voice for change. Okay, I want to tell you a little bit about how I've responded. I've been into this environmental thing for quite a while, but 18 months ago, I said, I need to study up about global warming. I need to really understand it. And here's my path. My New Year's resolution, and I began to pray about it. And by the time New Year's resolutions came around, I had 3. So the first part was prayer. And then my 3 New Year's resolutions for January of 2013. Become knowledgeable about global warming. Become articulate about global warming. And then see where it is that I can make a difference. The first 2 steps anybody can take. The third step is going to be an individual step. Where's that Holy Spirit calling you to make a difference?
How to bring awareness, global awareness among the people, that's important.
That's it. Hopefully we'll work on that. I'm going to ask the Knights of Columbus to help us about that.
Steve, isn't it possible that we could do things, for example, we have a lot of natural gas. Why aren't we converting all of our semis to natural gas that would reduce the CO2 emissions?
That's probably an excellent stopgap method.
That's where, I'm not saying it's a total solution.
That's right.
But to do nothing isn't going to
That's
get us
right.
there.
We need to reduce pollution. We need to
Yeah,
reduce
we are
pollution.
dealing with things like wind energy, which if the wind doesn't blow, it isn't helping us. And maybe as we get more efficient with that, we can do things. But until we get there, why don't we do some of the basics?
Absolutely. We've got to do everything. We got to do wind, we got to do lots of stuff. Okay, there's another path. The path I just showed you was my path. There's another path called the St. Francis Pledge. And there's a take-home sheet that will talk to you about that. It basically says, and this is presented by the Catholic Climate Covenant, and it has 5 steps in it: prayer, learning, assessment, act, and advocate. As you think about forming a new mindset, this will be a very helpful tool. It will allow you to look at your lives. It will allow you to look at your attitudes and make some changing in a very Catholic environment. How not to become discouraged. This is a very big, difficult issue. My personal path to not becoming discouraged is prayer, a simple prayer that I use often. The 108 is come, Holy Spirit, come. I also use a single Hail Mary, and I also use the Our Father. Thy kingdom come, thy will be done on earth as it is in heaven. Another very important way to not become discouraged is to find others to journey with you. If you try to make this journey by yourself, the world will overcome you. Finally, this is from the Christophers. Their slogan was, light one candle rather than the curse of the darkness. If it seems like I'm doing nothing, it's getting discouraging, at least light that candle. It's better than cussing about what's going on around us. Let's spend a minute about CO2 not being either red or blue. Nature does not care about politics. The Catholic advantage is that we have wise counsel to help us sort through the noise. There's a lot of noise out there. We are Republicans, Democrats, Independents, Conservatives, and Liberals. But we're all Catholics. We need to wake up our politicians. We need to let them hear the Catholic voice. We are speaking for our grandchildren. If we destroy creation, creation will destroy us. But we need to put a price on carbon. All of our decisions that we make, day to day, all the time, all the decisions that our businesses make are dollar-driven. They're based on cost. They're based on cost of incoming cost, how much stuff costs us. Right now, fossil fuels can pollute the atmosphere for no cost. And therefore, other technologies have a very difficult time competing because all of their costs are rolled into their prices. Burning fossil fuels is an integral part of our society and our economy. It's going to be a huge effort. It's going to be a comprehensive effort to change that. An effort as big as the mobilization for World War II. We've got to rebuild our industries. Now, it's not going to happen overnight. It's going to take some time, but we've got to be wanting that. We've got to be wanting to change our environment. And burning fossil fuels is a major cause of global warming. If we had a price on CO2 pollution, engaging the whole economy to solve the problem, we're a very creative society. Let's harness that. Most of our daily decisions are made on how much the things cost. Let's get the cost of carbon into that. One of those ways to put a price on carbon is a revenue-neutral carbon tax. It will provide a comprehensive solution. We'll tax fuels at the wellhead. The cost of carbon will be built into everything. The revenues will return directly to the households. If we can make it revenue neutral, it can be accepted by both parties. If it can be embedded in every cost, it can change our marketplace. It can change our industry. It can change the world. Free market will be motivated to reduce carbon everywhere. Right, I am a bit over, not too bad. I got one more set of questions, and then I got two more slides to wrap up. All right. For fairness to Jim, open up a few more questions. Yes, sir.
Yeah. How is it a free market if the government's going to decide what fuel should be used and what fuel should not be used?
They will not.
Then how do you change it from what we have now?
Okay, what we do is when you dig a ton of coal out of the hillside, when you go to sell that ton of coal, you put $13, some number into a pot. Okay, so now rather than that ton of coal being worth $120, it's worth $135.
Where is that pot located?
That pot is located in the government, and there is very tight rules on it. The pot is located in the government, and it says that all of those dollars have to be returned to the citizens. None of it gets used for spending.
So there's no bureaucratic cost to what you're proposing.
The cost for the distribution has been estimated at about 0.2%. 0.2% of the revenues collected. And yes, government does cost money. But that distribution there's nobody telling you what fuels to use. The EPA requirement isn't going to be important anymore. Okay? The rule is that we're going to make carbon expensive enough that every business is going to say, how can I change fuels? How can I reduce my energy cost? Where can I put the windmill in? Where can I put the batteries in? How can I increase the insulation in my company? All those decisions are not made by the government. All those businesses have what their bill is that comes in, and that is what my fuel costs.
Steve, that isn't really true, because MG&E says you will do this, this, and this.
MG&E is going to get the same bill from the electric company, from the coal company. Now, we do have to deal with MG&E because there's another governmental thing that's already established that controls public utilities. This does not change that. So,
President Obama recently came out with the new guidelines for the reduction, what is it, 30%?
30% reduction
on the year 2025? Is that going to help, or do we?
Okay, the question is that the EPA regulation that President Obama has just put in, is that going to help? It's not nearly the solution that I was talking about for carbon tax, but it's the only option right now on the table. And it's going to do more good than bad. It's going to reduce fossil fuels, hopefully move utilities to use less carbon. But I'd trade it in a minute for a price on all carbon.
I've got a comment more than a question.
Yes, sir.
And I'll self-identify myself as liberal. So I've been persuaded to this whole notion for a long period of time.
Yes, sir.
The thing that's intriguing to me is when you talk about the Catholic Church and the bishops getting involved in some way. I don't see how that happens. You talk about the church needs to speak with a clear voice for change. We have to hear the Catholic voice, okay? This is a partisan issue. This is a Democrat and Republican issue, and the one party who would be supporting of this notion that there is climate warming, that there's climate change, we have to address it. It's a huge issue and problem that we've got. Okay, the people who are for that are also...
Okay, I understand your question. Let me try to answer it.
I'm talking about partisans now, political parties who are in favor of that.
Right. What I'm saying is that the Catholic Church comes in...
I'm not done yet, though. Okay, so the contradictory part is the Catholic Church is concerned about whether or not pro-life, pro-abortion, gay marriage, issues of that nature. A bishop who would deny John Kerry the Eucharist because of his positions on certain things. Now you tell me how you reconcile that institution with this institution you've got speaking in a clear voice and a voice for change. I don't see it.
Okay, the bishops came out with a very clear document, an 11-page document. It's referenced on the bottom, you can get to it. And what they've said is that climate change is not a political issue. It's not a partisan issue. It's about the creation, God's creation, and it's about care for the poor. What they've said is that they are not scientists. They're going to believe these scientists. And what the scientists say is that the carbon dioxide that's being gathered in the atmosphere is causing atmospheric increases, temperature increases, and those things are harming our environment, harming us, and we need to make some changes in it. What the bishop said is above what the politicians are saying. This noise here about whether it exists or not is very important, okay, because we live with it all the time. But the Pope and the bishops are saying, we gotta get beyond this, we've gotta find solution. And there are 97% of the environmental scientists that are working in the field today tell you that climate change is real. There is no other area of scientific investigation where there's anywhere near that kind of coherence. The confusion that we see is confusion that has been wrought by interest, public interest. Here's what I want to leave you with, the takeaway from tonight. Global warming is real. Human activity is the major cause. It is changing the world around us today. If we do nothing new, business as usual, it is going to be very bad. Again, quoting Pope Francis, if we destroy creation, it will destroy us. I come back to the prayer I started with. Come, Holy Spirit, come. Each of you, please, when you get confused about this, when you think about this, when you read articles about this, start with a prayer. Knights of Columbus, what I'm asking of you is to help spread this message in the church. Everyone here, I would ask you to prayerfully consider taking the St. Joseph's pledge, the St. Francis pledge. And I've got some handout sheets for that. We as Catholics have a powerful voice in our society. Let's use that voice. Finally, if you want more discussion, if you want to talk some more about it, we're considering starting a discussion group or some more activities maybe in the fall. I've got 3 sign-up sheets up here. If you've got any interest on continuing the study, continuing the work, so that you don't have to walk alone, please sign up and we'll see if there's enough interest. We can continue to do some more things. Again, I really appreciate your attention. It's a very lot of material to cover in a very short time. I hope I've whetted your interest.
Thank you, Chief.